Vapor pressure. Consider a container open to atmosphere with water up to a certain level. Zooming at the surface of the liquid, we can observe that molecules are held together with the help of intermolecular cohesive forces. The topmost layer has least number of attractive forces as it is directly exposed to the atmosphere. We know that molecules vibrate about their mean position. Thus a sufficient momentum to overcome the intermolecular cohesive force will allow them to escape into the atmosphere in the form of vapors. Consider a container isolated from the atmosphere with a fixed lid, and air is vacuumed out, such that the space between lid and fluid surface begins to fill with vapors. This happens as vapor begin to exit fluid body. Then re-enters again with a certain force on the fluid surface. At equilibrium, vapor exiting from surface becomes equal to vapor entering. Pressure exerted by vapor on fluid surface at equilibrium is called vapor pressure. If the lid on a sealed liquid-filled container is moved, the space is filled with vapor. As it depends on molecular activity, it depends on temperature. Vapor pressure increases with the increase in temperature. Higher temperature will contribute in momentum increment, causes more vapor to exit and re-enter the fluid body. Boiling occurs when absolute pressure becomes equal to vapor pressure. When water is heated to 100 degrees Celsius, at standard atmospheric pressure, the pressure exerted by liquid becomes equal to pressure exerted by its gaseous form, from same matter. As temperature increases over 100 degrees, the gaseous state becomes dominant. The liquid begins to convert from its current state to gaseous form, that is vapors. The graph between altitude in 1000 meters against boiling temperature shows that boiling point drops with increase in altitude, which translates to decrease in absolute pressure. If we go up to an altitude of 9000 meters above sea level, the absolute pressure is equal to 30 kPa, for which boiling point occurs at 69 degrees Celsius. We can control boiling at any pressure by changing temperature. Similarly, at any temperature by varying pressure. Importance of vapor pressure in fluid mechanics is not limited to boiling. In flowing fluid, near valves or pumps, liquid often enters region of low pressure, as low as vapor pressure, causing it to boil and form bubbles. As it passes to region of high pressure, these bubbles collapse with intensity to cause structural damage. This formation and subsequent collapse of vapor bubbles in a flowing fluid is called cavitation. Thanks for watching. For further lectures, go to AACOE Online and subscribe to help support free education.